So the first thing I need to talk about with you guys is finals. That is the most important thing. So if you have any questions, just ask me. Okay, that's you can always put in the chat room. So please put this in your calendar or your cell phone to remind yourself that my final is gonna be May 12th on Wednesday. Okay, let me repeat. My finals will be on May 12th, the Wednesday. 12:30 is the review time. 1 o'clock to 2:30 is the final time. I'll go to the questions. Yep. And if you, Linda, we haven't taught 9.3 yet, but once I go over 9.3, I will look at, because today we go over 9.2 and 9.3. So most of the questions from what we're looking for is 9.1 right now. And then definitely I will do 9.3 and question 6 in this case. Okay. So what I want to point out here is this is more important, it's your finals. So your final is May 12th on Wednesday. We will be going over chapter 7, 8, 9, and 10. So there are 4 chapters. As usual, you can have 1 page of the cheat sheet, just the front page, not the back page. I think you guys remember the midterm. I do check your 1 page cheat sheet. So as you know, you guys do that. So 1 page, make sure the back page is blank. 12:30 to 1 o'clock is the review for the finals. You probably will get this review next week. Then 1 to 2:30 is your finals. If you cannot attend this final during this time, you need to talk to me like soon or now. I just want to point out to you guys that I won't be around on Thursday, May 13th. I will be out of town. So I just want to point out to you that if you guys want to redo the, if you cannot take this day for your finals, then you have to take it the day before it, which is the Tuesday or the Monday, the 10th or the 11th. So you cannot take the finals on Thursday, the 13th, because I won't be around to give tests because I'll be out of town. So if you cannot come during this time, please let me know now. Send me an email. So this is very important. Anyone have any questions with your finals? It's going to be on Zoom, like the first test. It will be the same same type of format. The first 10 questions is multiple choice, and then you got like 4 open-ended questions. Okay, like 4 to 5 open-ended questions, like what you do in first test. So those students who did the first test, the midterm, you guys are running out of time. I do really want you guys to do this review that I will post it next week, and make sure you time yourself. How much time do you spend on it? Because you only have 1.5 hours to do your test. Mostly I will give another extra 10 or 15 minutes. That's it. That I won't give you like another 30-40 minutes. So by 2:30, 2:40, you should be done. And then after that, you will have another 10 minutes to upload that into your D2L. That would be the so by 3 o'clock, you should have everything in D2L and everything. So after 3 o'clock, I will not even accept anything. So make sure you guys got this finals piece here. So please put this in your calendar or remind yourself somewhere, that this is your finals. And do not forget, if you didn't take these finals, your final is a 35% of your final grade. Your final is 35%, so you actually will fail my class. Okay, I just reply to you. Please, this is very important. Okay. So there are some questions on 9.1, which is number 8 and number 9. So I'm going to go through these 2 questions here. So
quick question about the final. How many questions are there?
The same, 10 multiple choice and 4-5 open-ended.
Okay.
The same as your midterm. So you have 10 multiple choice and 4 to 5 open-ended questions. All right, question 8 and question 9. So we'll look at these 2 questions that you guys asked. So this is about 2 proportion. So we have this virus, rhinovirus. So in this case, this is to test our effectiveness. 40 of 47 was treated by this echinacea for this, and the placebo group is given us by 76 Again, 9.2 and 9.3, if I have time, because I haven't teach 9.2 and 9.3 yet, so I don't know how you guys managed to do the homework. So these are going for placebo groups. So you want to test the claim that the Ichina has effect on the infections. So what is the meaning when I say when you want to claim that this has an effect?
That you measure.
Is that equal? Is that not equal to? Is that greater or is that
Equal.
less than?
Not equal.
Okay, so when you ask for an effect, it's the same thing as the same. That means has the same. So you will go for the not and not equal, the equal and not equal to in this case. Yes, Teresa, you're correct. Okay. In my test, I won't use this word. I will use the word they are equal, they are greater, they are less. So I won't use like this word effect or no effect or something else like that.
Okay. Another question real quick. So what's due tonight exactly at midnight? Because on
9.1.
okay, because on Pearson's website, it says that 9.1 and 9.2 are due.
Oh, no, only 9.1. I'm going to change this now. So do not worry about 9.2 because if you did it, which is good, I'm going to change it right now. So it's only 9.1 is due tonight. Do I put 9.2 also?
Yeah. Thank you
Okay,
for that.
I'm going to change it now. So please 9.1 is the only one is due tonight, not 9.2. So don't, oh, yep, sorry about that. So 9.2 is not due. So do not worry about 9.2 is not going to be due. 9.1 is due tonight, 9.2 is due next week. And no one emailed me. Why you guys don't email me and ask me to confirm? Because I haven't teach all 9.2 yet, right? So today we will start doing 9.2 and 9.3. So yeah,
because
so
you said it last week that only 9.1 was due, so I didn't say I didn't say anything.
Yep, please, yep. So what's that? Usually you guys always on top of me. I was like, oh yeah, David, why 9.2 is due? La, 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 la. So yeah, no. I want to point out to you, 9.2 is not due today, only 9.1. And thank you for like clarify with me. Yep, so only 9.2 is due, 9.1 is due today, not 9.2. Okay, you guys always on top of me, usually say, what homework? So sorry about that. I am apologizing that first. So so we're gonna continue with this chapter, question 8 here. So this is the one. And now we will do your test statistic in this case. So you will have to go to your StatCrunch and they will tell you that the first population here is the first sample is using the Echinacea, and then the second one is using the placebo. So again, you go to stat, you go to proportion stat, to sample with summary. Okay, so so the first one is success. So this is 40 people out of 47. So 40 people out of 47 people are treated. And 76 out of 92 is treated. And we are doing equal and not equals to, and for the hypothesis testing. So when you hit compute, so this will be your z-stats in 2 decimal place. So that will be what, 0.37. And then the p-value is this one in 3 decimal place is 0.708. And then you look at your alpha, since your p-value here is 0.708, which is higher or greater than 0.01. That's the alpha that we use here. So the p-value in this case is greater than that. So when it's greater, do we reject or fail to reject?
Fail to reject.
Fail to reject. And every time when you fail to reject, there is, now this is very, now if you put this, they will mark you wrong. Yeah. Oh, it's right. Let me see. That is why, yeah. Again, in your test, you won't get this. You should be saying there is not sufficient evidence to support the claim. Yeah. So make sure you write down, make sure you know how to write. Every time when you fail to reject, it's always is not sufficient evidence. When you reject, there is sufficient evidence. So make sure you guys know about this, how you write it. And in the, I will tell you in your finals, is mostly is you have to handwritten all by yourself. Now this question, they give you the 99% confidence interval. I want to tell you in the test, they won't even provide you the 99% confidence. Do you guys know how they get the 99% confidence, the 99% here?
Yeah, the difference of significance level.
So are we using 1 minus alpha or
Yeah.
1 minus 2 alpha? That's why in the test, you won't get this. That's why sometimes I really don't like this online homework, because they will tell you. So make sure you guys know that this is our, so if you have a one-tailed test, if you have a one-tailed test, you will use this. One-tailed means less than or greater than, right? If you have a two-tailed test, you will be using this. That means not equals to. So since this is a two-tailed test, so we are using the 1 minus alpha, and our alpha in this case is 0.01, the 1%. So that's why this is a 99%. That's why your whole online homework is very nice. They give you that 99%. Again, in my test, you won't get this. So that's why you need to know this. This is very, very important. So if you guys are, if you guys have your cheat sheet, make sure you have this in your cheat sheet, because you'll be in big trouble if you don't get it. And then
Are you gonna post something where we have like a practice like you did last time?
Next week.
Okay.
Next week. Your review. So what we do here is we just need to go to the confidence level, that everything's the same, and then change this to a 99%. And then so that will be your lower and your upper right here. So your lower in this case in 3 decimal place is negative 0.143, and upper in this case is 0.193. Okay, so this is, and now we look at the confidence interval. Did your confidence interval include or does not include 0?
Includes.
Because if it's 1 positive, 1 negative, 1 positive, it will be include. So if there include, so there is or there is not significant difference. So this is back to your chapter 9 that we talked about before. If you remember this, when I say it is include 0, it is no, yes. When it includes 0, no significant difference. So we will be using there is no significant difference here. So there will be no appear to be significant between this. So if they're not, so in this case, this conclusion is going to be the same as this conclusion. So you say it's not sufficient evidence. So in this case, so this is not sufficient evidence. So make sure that I just want to point out to you that these two are the same conclusion you will get. Okay. Then does it have an effect? So in this case, you say that is not evidence support this. So that means that this Echinacea actually has no effects. Okay. Does not appear. So the Echinacea does not appear to have any effects, because you reject. You say you is not supporting the claim. So that means this treatment has no effects. You guys all right? You guys good with question 8? Question 9 is the same thing. 2 different simple random samples are drawn from 2 different populations. One consists of 40 with 19 having common attributes, and the second one has this many people and this many people have common attributes. So you want to compare the hypothesis of P1 equals to P2. so when you want to compare the results of P1 equals to P2, then what will be your hypothesis testing claim? Your statement is that not equal to, is that greater, or is that less than?
Equal to?
Which one is that? Not equal? The H0
Not
is
equal.
always equal. Yep, we always do it. Again, in the test, I won't do this kind of work. I would say that test the claim that the first population is equal or is the same as the second population. So I won't use P1 equals to P2. I don't know why. Sometimes the online homework give this kind of questions, which you know, they're not very uniform or the same as the one that you will get in the test because of the wordings. So you need to go, and then you have to do your identify your test statistics. So you need to go to your StatCrunch again. And for this question, we will need to go to your stats, go to your proportion stat 2 sample with summary. First observation is the first group, which is 19 out of 40. And then second one is 1490 out of 2100. And since we are doing equal and not equal to, so this is the one that we will use and you will compute. And the test statistic is the one that is on the Z-stat. So it will be negative 3.22. And your p-value will be the next one. Did they ask? Oh, they're asking for critical value. So that's the reason why that this is. So this is not asking you p-value. This is asking critical value. So again, in the test, I won't ask you critical value. I will ask you the p-value. So does anyone know how to find a critical value here?
Nope, that's why I asked for help.
Good. Okay. So so we're gonna talk about this. We really talk about this in chapter 8 to find the critical value.
Employees and jobs that are low wage.
So if you look at 8.1, we have a table.
Oh,
Isn't that the region that does not include the,
Right now, there you go.
yeah,
So this is 8.1. So if you guys, if a question is asking for critical value, I would recommend to do this. Again, class, if you have the cheat sheet, put this in your cheat sheets because this is to find critical value. Are we doing proportion? Or are we doing mean in this part?
portion?
Proportion. So because 9.1 is proportion. So we will talk about stat calculators, normal, mean 0, standard deviation 1. So we're going to do this one. So I'm going to take up my StatCrunch here. I'm going to kind of like minimize that. I'm going to go to this. So we go to stat calculators, and then you go to normal. Okay. And you keep the mean 0 and the standard deviation 1. Are we having two tail left or right tail in this question?
Is it two-tail?
Yep, because we use not equal to, right?
Yeah.
So it's a two-tail test. So if it's a two-tail test, then you use the first one. So you will need to take this as greater, and then leave this blank, okay? And then this one, you need to do alpha over 2. What is alpha in this case?
0.05.
No, it's 0.01 in this case. Okay, so you need to divide. So you take 0.01 divided by 2. Okay, so you do this one. So this is your critical value, but do not forget that your answer has to be what?
A negative and a positive.
Yep, because it's a two-tail test. So this one only gives you the positive. The negative one is exactly the same. So this is your answer. So what you need to do in this case is you just need to put 2 answers here, exactly the same number, 103 decimal place. So it's negative 2.576 and 2.576 because it's a two-tail test. So you will have two-sided. So this is how you find your critical value. Now, usually what you need to do here is this is something that I should take it out in your homework. What happens here is that since this is your critical value is negative 2.576 and because they don't use the p-value here. So anything that falls inside this shaded region, you will have to reject your null hypothesis. We call this as your critical region. And if your value fall in between this, then you fail to reject. So how do we figure out what value to use? Is your test statistic. Negative 3.22. That is your test statistics here. Can someone tell me where is negative 3.22 on the number line here?
It's going to be inside.
To be inside here, right? So that means you are rejecting here. You're rejecting your null hypothesis. So what happened is that, so the test statistic is inside the critical region. So if it's inside, we will reject the null hypothesis. And do you guys know what happens every time when you reject? That is sufficient or that is not sufficient evidence?
It's sufficient.
I think you guys know when you say reject, you always do sufficient, fail to reject is not sufficient. So this way that I show it to you, where you need to find your critical region and then use your test statistic, this is what we call as the critical value way. So actually there are two ways for us to perform, three ways actually, but we use the p-value methods for the most of the time. So this is the only question that use the critical values method, which I won't call you to do it in your test. I should take this question out. And then, so since again, this is a two-tailed test, so we will be using this formula to figure out your confidence interval. And again, our alpha is 0.01. So that's why we are using a 99%. So what we do here is, in order for us to find the confidence interval, is you go back to your previous, you don't use this calculator anymore. You go to the first result, this fellow, and then you go to option, you go to edit. Remember last time we do a hypothesis testing, now we're going to do a confidence interval. So change that to 99% and you compute it. Natasha, I might need to mute you. And then, so what you do is, this is your limits here. So your answer in this case will be negative 0.439. No, actually it's 440. The 5 is big enough to round up. Negative 0.030, because again, the 5 is big enough to round up. And then, so then the question is asking is, do 0 is in this interval? Since you look at this, but both negative, so 0 is not included in this interval. So that means that it will be, which is the same result as you guys have on top. You will have to reject your null hypothesis in this case. So I would just want to point out to you guys that this confidence interval method, this is a third method that is actually the same as the one. So so these two results should be the same. So the two results should be the same. It's not different. If you got different, so since they are the same, so what is the meaning is there is sufficient evidence to conclude P1 is not equal to P2. So that means the hypothesis suggests that P1 is not equal to P2, and the confidence interval suggests that P1 is less than P2. Does anyone here know why? Oh, no, this should be, I'm sorry, this should be not equal to. This should be the same, sorry. Yep. So what I want to point out to you here, that your both hypothesis testing and your both confidence interval should show it. Actually, your confidence interval suggests P1 is less than P2. That's why I use the word less than. The reason why is because both of these are negative values. However, the reason why they mark me wrong is because we are testing for equal and not equal to. We are not testing for equal and less than. So if you do D equal and less than, then you should have both of them have show less than and less than. So what I want to point out again to you guys is these are going to be the same result as both of these hypothesis and confidence interval. The result should be the same. That's what I want to point out. Okay, so so this is how we do the proportion, and don't worry much about this question 9 because we are not going to do the critical value methods. So that is what I want to point out to you. So don't worry much about this question. Just forget about the critical value, do back the p-value that you guys used to do. Okay. All right, so the next thing we're gonna move on to our real work today, which is chapter 9. So so 9.2 is talking about the claim two means with independent sample, and 9.3 is also talking about two means, but it is going to be with dependent sample or match pair. Okay, so when you guys do the two means with independent sample, so what is independent sample? Independent sample means that the one population is not related with the other population. That means that you got two groups, and these two groups that you're comparing has nothing related, nothing to do with each other. So this is 9.2. For a dependent sample or matched pair sample, this is where you will have the two groups is matched based on some relationship, like husbands and wife, like boyfriend, girlfriend, siblings, you know, something. So there is a relationship, so you match together, or you can get a measurement from the same subject, usually before and after. So when you have a dependent or matched pair, there are two choices. One choices is one of the two groups is related, somehow related to each other, like husband, wife, and you know, family and stuff like that. Or you can pick one subject, and that subject actually give us two results, before and after. Example will be like weight loss. So so if you want to study if this group of students that I have in this stats class are having weight loss, are successful doing weight loss with this David's diet. So what you do is you go before, that means before the diet starts, you wait. And then after that, 3 months later on, after you do your diets, you wait again. That will be what we call as match pair. So make sure you guys know this. So very important. So again, 9.2 is for independent. So make sure, and 9.3 is for dependent. For example, for independence will be like if I separate this group into male and female. So it will be two separate groups. So that means that either you belong to female or you belong to male, and these two groups are not related to each other. I can also break this group into age group, like age that is younger, which is less than 21 years old, and I can break the group into age that is older, which is greater than 21 years old. So I can break these two groups. That means you only can belong to one of this group, either this group A or this group B. For the match pair case, we can talk about the weight loss, where you have to give your weight before, after. We can talk anything that has that you have to measure yourself twice. That means before one time and after one time. I mean after the second. I mean that after that you got measure again. Or you can talk about the relationship, husband and wife, or brothers and sisters, and something else that has a relationship. You guys clear with this one, class? This is how you separate these two sections, and a lot of students, you know, get these two confused when they do my finals.
Sorry,
So,
my dog was barking. So wait, so the weight loss one is dependent?
Yep. That because you have to wait yourself before, and then after that you have to wait yourself after, right?
Okay, cool. Thank you.
Yep. Same thing with like you want to figure out if you went for a tutoring session, if the tutoring sessions really improve your grade. So what you do is you will take a test before you get your tutoring section. And then after you finish 3 weeks, 1 month of tutoring sessions, you take another test and see if there's an improvement. So that is before and after. So usually you have the keyword before, after means you do something before, and then you after that you do after that. You two measurements in this case. Let's let you take a look at this question. So so I want you guys to read question 1 and tell me, is this independent or is that dependent? Read question 1. Is this independent or dependent?
Dependent.
This is dependent. So that means you have to use 9.3. So if I came up this question in your test, if you do 9.2, you get big 0. How about question 2? Well,
Independent?
yep. Because you can only be you can only be either the residents of Alaska or the residents of Hawaii. I don't think so. You can become 2 residents at the same time. And residents of Alaska has nothing to do with residents of Hawaii because they're 2 separate groups. So for this case, you will, if this question come up in my test, then you will have to refer to 9.2. You guys okay here? So that's the difference. So that's see the word before and after. Okay, and then this one is 2 completely non-related groups. So when you do this is 9.2. So when we do 9.2, so we have all these notations. And again, when you see all these 1 stands for population 1, and then you will replace all this 2 for population 2 because you got 2 groups. So let's say population 1 is for Alaska, population 2 is for Hawaii, something like that. Mu in this case is your population mean. Okay. Sigma in this case is population standard deviation. So for 1 means the first population. N is in this case is your sample size. So how many, like in this case, there are 1,200 people in Alaska. So they picked 1,200 people. So that's sample size. X1 in this case is the number of success. That means that out of these 1,200 of people, how many of them are Republican? Let's say if you have studied for Republican or Democrat, something like that. S1 in this case is your sample standard deviation. So do not forget, class, that usually the population 1, we use Greek letters like mu and sigma. And if you use the alphabet A, B, C, D, then it always belongs to the sample. Okay, so these are all belongs to the sample. This belongs to population. And the rest, then you change everything to 2, then the same thing, but it goes to the population 2. So the requirements for this 9.2, where you do 2 independent sample here, is first thing first is we always assume that the sigma, the population standard deviation for both populations, we cannot assume they are equal. Okay, usually this is given. So you do not need to worry about this. So this is always checked. So you do not need to test this requirement. Okay, this is always checked. So actually you can cross off the first requirement. But the reason why I write down, so you guys know that this is must to have, but I will tell you that this is automatically will work. Okay. Second requirement in this case will be saying that the 2 has to be independent, like what we just did over here, this case. Okay. So again, if you do dependent, no good. Simple random sample, and it has to be either the population has to be either greater than 30 on both population, or they all has to come in a population with normal distribution. And this is back to what we have last time. This last requirement is very you do not need to fulfill it. So if you do have a small samples, then make sure that there are no outliers here. Okay, so actually, if you got a smaller sample like 20 or 25 or 16 people or 15 people, then make sure that these people are not outliers in this case. Okay, you do not need to worry about doing this crazy test statistic. You will be crying. You do not need to worry about the degree of freedom because StatCrunch will give you that. So this is all done in StatCrunch. You do not need to worry about finding the E, because remember last time how you find your margin of error, you take the upper minus the lower divided by 2, right? So this is usually how you, if the question do want you to find the E, your StatCrunch will give you the upper and the lower, you just subtract them and divide by 2. Same thing like what you did in chapter 7. So StatCrunch in this case is, we got 2 types. Either you do it with the data, you go for t-stats, 2 sample. Either you do it with data or with summary. With data means that you got data that is imported to StatCrunch. That means that if you do your online homework, you import all those data, the whole table file into, then we use data. Or I call you to, if it's tests, I will call you to use data files like bears and and all those, like all the data files that you guys found in the StatCrunch. So if you use that, then you use data. But in a test, if I give you tables, you cannot import it. So you actually have to manually type it out, unfortunately. And I won't give you a lot of numbers to type out. Okay, just maybe 15 or 20 numbers, and make sure you don't type out the wrong numbers. A summary means that if the question provide you summary statistics, means the question give you the mean, the standard deviation, the sample size, then you use this. And again, all chapter 9, no matter it is proportion or mean, you have to perform both hypothesis testing and confidence interval. So make sure you guys know which one you're doing. Like usually we do hypothesis testing first, which is the 7-step procedure. And then you do the confidence interval. And the confidence interval, I don't provide you the confidence level. So remember this is still a do you still remember the 2 tail 1 minus alpha, 1 tail 1 minus? This is still used in this section, the whole chapter 9. So in whole chapter 9, so make sure you know that if it's a 1 tail test, your confidence level will be 1 minus 2 alpha, 1 minus 2 times alpha. If it's a 2 tail test, then the confidence level will be 1 minus alpha. So this is the same thing as what we did before. And so chapter 9 is the whole thing when we talk about confidence levels. And we also talk about what happens if it's captured 0 or not. So remember last time in proportion, we talked about the 3 important things. One thing is if it includes 0, like what we did here. So this is also applying in 9.2. So this applies to 9.2, but not 9.3. So it only applies to the independent part, not the dependent part. So this is having, and this is also applies to 9.2 and 9.3. So this actually applies to both of them. For the one that I told you, the confidence interval, 1 minus alpha and 1 minus 2 alpha. And the last important thing that we talk about here is the changing. Remember, switch population. When you switch your population around, your confidence interval will be switched around, and your sign is also switched around. This is also applies to 9.2, but not 9.3. So so these 3 important informations that I taught last week with 9.1 will be applied mostly to 9.2, all 3 of them, not in 9.3 except for the confidence level piece. Okay, so the only difference here is instead of using P, this will be using mu. So it's mu1 is equals to mu2. So if you have if you go for 9.2, so we don't use P in this case. We will use mu. So this is for 9.2. So we, instead of all this P1, it'll become mu1 and mu2, because P stands for proportion, mu stands for mean, and we are doing mean in this case. Anyone have any questions with this? With 9.2. Okay. So so example is, so let's say that this is the 2 populations here, where the first population is women and the first population is men. Sorry, I didn't read. So the first population here is men, and the second population here is women. And this is your confidence interval that you get. can you tell me what happens to your confidence interval if I switch them around? That means the population 1 is women now and the population 2 is men. Anyone? What is your answer? This is the before. So what happens when you switch them around? What would be your answer in this case?
Switch,
This is all coming up in your finals. That's why I need to.
oh my god.
Wouldn't it just be like backwards?
Yep. And what happens to your, so what happens? So the 17.32 become negative 17.32.
Oh, okay.
And then mu W, I just use W for women minus mu M. So usually we don't use 1 and 2. Try your best not to use 1 and 2. Use like M and W or L or R if it's like left or right-handed, or some like Alaska and Hawaii use A and H. So at least we know what you're talking about. And then the negative 1.61. You guys okay here? Okay. B is asking for what does the confidence interval suggest? Now you don't do we are 95% confident. Remember last time when you did we are 95% confident that the interval is between and this thing. The one that you guys do, this is wrong. Don't do this. We don't do that. That is wrong. So what we're talking about in this case is who is which one, since you get this confidence, the mean of women minus mean of men, they are both negative. So what can you tell me if both of these are negative? What can you tell me? Remember last time? If they are both plus, then that is a significant difference. P1 is greater than P2. We don't use P now. We just use mu1 is greater than mu2. And what happens if both of them are negative?
There's no significance.
So that is also significant difference, but mu1 is less than, right? And then what happens is one is negative and one is positive.
No significant difference.
Yep. So it's the same thing that you guys learned before. No significant difference. Sorry, I cannot spell. Mu1 is equals to mu2, right? And this one captures zeros. Every time when you have a minus plus, those two can. So what can you tell me now if both of these are negative? Because we got both negative here, right?
Significant difference.
So this is a significant difference.
Mu1 is less than mu2.
Can you tell me what is 1 and 2 here stands for? Is that man or woman? 1.
Woman.
Yes, that means the woman's height is what? Less than the man's height. You guys with me here?
Can you explain again why we need to convert the positives into negatives?
Because we changed your population around. So this confidence interval is where the first population is man, and second population is female, women. So what happens if I switch your population around, like what we did here in 9.1? I think we did it before that. Remember last time I said this is this number, and then what happens if I switch your population around? Your confidence interval will be switched around. So this is the same, and then your sign will be switched. So this is the same thing that we do over here for this question.
So can you explain the confidence interval, what that means again?
Which, the B part?
Well, I just don't, I'm just maybe not thinking right today, but I'm kind of confused. at why do we need to make that negative? I get the switching around, but
We
still-
did this before in your stack cruncher. So let's say that this is your let's say we have negative 0.4395 and negative 0.0295. So if I switch these numbers around, I'm put 19 and 40 here so I can remember this. So this is what happens to the question I'm asking is I switch these numbers around. So that means I switch one to the other. You notice that your confidence interval, is that different?
Yeah, you missed. It's 19 and 40. This the second one is not 14, it's 19.
Oh, thank you.
Mhm.
So you find out that when you switch this around, your interval is going to be like that. And you notice that it is exactly the same as the before. You just switch around and all your sign will switch. That is the nature of it.
Can you go back to the edit version? So, yep. So what you're saying is that if sample 1 got the numbers that sample 2 got.
That means that let's say sample 1 is male, sample 2 is female.
Okay.
So this is where the sample 1 is male, let's say, and sample 2 is female. You will get this.
Okay.
And
so
if I put sample 1 is male and sample 2 is sample 1 is female, sample 2 is male, you will end up with that.
okay.
So that's the meaning when I say switch the population around.
Okay, that makes a little more sense.
So that is what's going on in. So this is proportion. So it will also happens with the mean.
Okay, thank you.
All right. So so we're gonna read this question here, and then we'll do some 9.2 what some of you have. Assuming that 2 samples are independent, simple random samples started from normal distribution population and do not assume the population are equal. So this covers up your requirements. The reason why they give you this is because the requirement says it need to be simple random sample, it has to be independent, you have to be. So this is just for requirement. So you do not need to check your requirement in this case. So because of that, so you do not need to check your requirement. Okay, so do the following. So weight of the quarters are designed in vending machines. So the weight of 40 samples of pre-1964 quarters. So they break into 2 different quarters. One is quarters that is made before 1964, and one is made after 1964. And 40 of this before one has the mean of that and percentage of that. And 40 sample of poles have the mean of this and percentage of that. So as you guys know, that is annoying when you go to vending machine, you try to put quarters in there and some of the quarters are rejected, right? You keep on putting it and keep on rejecting it. The reason why is because of this issue. Some of your quarters might be too light or some of the quarters might be too heavy. So they got rejected. That's the reason why. So in this case, you need to use the significant level test that I'm under the claim statement that the pre one had with a mean weight that is greater than the post. So in this case, the pre one is your first sample. So this is your first sample, P1, and the post one will be the sample 2. Okay, so this is 1 and 2. And it says greater. So we're gonna do a testing. So because we have go through the 7 check, the requirement here is already checked for us is because, or you do not need to check this because of the assumption is redone due to the assumption. Okay, so if you have mostly if I give you this kind of assumption, so you do not need to really go through the requirement check here. Then the second one is you need to write your hypothesis statement, H0 and H1. Now, because this is your pre and post, so I will say mu pre is equals to mu post. Usually they use 1 and 2. Mu1 is equal to mu2, but I just use pre and post, so we kind of know pre is the first one, post is the second one. This is a bit more legitimate than just writing 1 and 2. Since you want to test for greater, so mu pre has to be greater than mu post. This is what the question wants us to do. So this is your hypothesis testing. And then you need to figure out what is your sampling distribution. Don't forget unit sample. Now, when you do sampling distribution, if it's a proportion, it's always Z. If it's mean, it's always T, fixed. I don't care if it's a 1 sample or 2 samples, it's always fixed. Okay. So what you need to do next is your test statistic. So you have to go through your StatCrunch to do this. So in your StatCrunch, you need to go to T distribution. So you go under stat, go under T stat, go under 2 sample because we got 2. This one, since they give us all the summary, so we will go summary. So again, you need to enter this without rounding these numbers. So the first sample mean in this case is 6.19267. Unfortunately, you cannot round it. Standard deviation is 0.087 with the sample size of 40. This is for the first sample, the pre. The second sample for the post, the mean is 5.6393 and the standard deviation is 0.06194. And we also have 40 questions here. Then they say that pool variance, the default reset change up. So do not click on it, just leave it blank because we always do not want that. So just leave this follow blank, don't do anything. And then we do the hypothesis testing. So mu1 equals to mu2, which is always 0. And this one is mu1 is greater than mu2. So we always use 0 for chapter 9. So you usually don't change this number. You only change the sign. And then once you hit compute, so your test statistic is this fellow, and you can tell it's T because it's a T distribution. So it's 32.77. And then the p-value next, then the p-value will be the one that is asking for next. So the p-value in this case will be, what was that? So if you see this in your test, less than 0.001 means this is 0. Okay, let me repeat. If your p-value is giving you this number less than 0.0001 means it's 0 in this case, or 0 plus. That means it's very, very small, like chance of you getting lottery. Okay. So this is the first step, second step, third step, fourth step, which is these two. Now we do the fifth step, which is now you look at the p-value and the alpha. So since the p-value here is so small that it's definitely less than alpha, because our alpha in this case is 0.05. What can you what's the decision? Reject or fail to reject H0 when your p-value is less than alpha?
Reject.
So we will reject H0. And so now because we have, remember the conclusion that we make back in chapter 8, this one. So does your claim statement includes or not includes equality here?
Not include, and there is sufficient.
Teresa, you're quick. So, so in this case, oh, I'm sorry. So because they are greater, so we are greater, so that means this is not include equality, and you are rejecting H0. So, so which conclusion you need to take? 1, 2, 3, or 4?
1.
first one, yep, because it has not include equality and you reject H naught. So this is the conclusion you need to write. So there is sufficient evidence to support the claim. So this one will be, there is sufficient evidence to support the claim. And the claim that, again, I don't have time, so you just copy all this and paste it. The pre is greater than post. Again, don't do this in your test because I don't have time to write it out. So in the test, make sure you write this up, like copy and paste, your claim statement here, because you won't get full points if you do something like that. So this is part A, where you do your hypothesis testing, all 6 steps, and we don't have a question. Usually 6 steps, we don't have a question the 7th. Now we have to construct a confidence interval. So in order for us to construct the confidence interval, you need to know how to find your confidence level. So based on this, is this a 1-tail test or a 2-tail test? Based on what you do in your hypothesis statement.
1.
1-tail test.
Oh.
So
1.
because it's a greater, so we have to do 1 minus 2 alpha. So that is your, so if for your confidence interval, you have to do 1 minus 2 alpha. Alpha in this case is 0.05. Can someone tell me what is that is? Point. Hmm?
0.9.
0.9, right? Okay, so now what you do here is you go to your StatCrunch, you just change, edit it. We're not doing hypothesis testing, we are doing the confidence interval for 90%, 0.9. So this is your answer in this case. So it's 0.5252. So the confidence interval in this case is 0.5252. And I don't know what's the other one, let me see. 0.5815. And don't forget it has units, and the units here is all in grams. Okay, so this is how you do part B. So mostly part B in this case is how you find the confidence levels, this is the most important piece. This is actually a typo. Do post 19, oh no, it's not typo actually. Yeah, this is not a type. Do post 1964 quarters weight less than before pre 1964? So this is actually, when the reason why I say it's a typo is usually I don't use this word. This is actually is asking is do pre 1964 quarters is greater than post 1964. It's the same thing. They just change the wording here. Okay, so in this case, what do you notice here is when you say this in your hypothesis testing, what does that mean when I say it is sufficient evidence to support the claim that the pre is greater than the post? Means what? Do you agree with this, that the old quarters are heavier than the new quarters? When you look at this, we already proved that this is what the pre is greater than post, right? And if you look at this, what can you tell me? Are they both negative? Are they both positive? Or are they one negative, one positive?
2 positives.
And what happens if they are both positive?
There is significance.
There is a significant difference, means what? The first one is greater than the second one, right? So means your pre is what? Greater than your post. So what happened is, do you agree with this? The answer will be yes, because both the hypothesis testing and the confidence interval shows that your pre is greater than your post. Okay, both of them shows that. Okay, you saw why iron vending machine affect very much by the difference. the reason why is because the difference is too small to detect by the machine. So do you guys know what is the difference between these two? If you take out your calculator, if you take the mean, 5.6393 subtracted by 6.19267. This is a 0.56 gram. Do you know how heavy is 0.56 gram is? You guys know how it is as heavy as 1 hair. That is how heavy is 0.56 gram is one hair. So that's the reason why that your vending machine cannot tell the difference, because it's just a hair different. Okay, so that's the reason why that. Yeah, make sure you type Huang, make sure you type present here. Okay, so this is how we do this type of questions. So again, this kind of questions will be asked in your test, and this is quite a lot of points. So make sure you guys, yep, we'll take attendance now. So please go ahead. So make sure you guys know how to do these kind of questions. Okay, so when you guys do the homework, so I will do 9.2 question 9 and 10. So because I'm running out of time here. So then we'll talk about 9.3 quick. Then you will see. So we'll do 9 first. Tapu, maybe we will do 10 next time. Okay. So this is the question. This is the data.
Excuse me, is the 9.2 due tonight?
No.
Okay, I thought it was. Thank you.
I will change it. That means you're not paying attention in my class. So this is talking about the strong. I don't know what is strontium. I think I do not know what that is. I have no idea what this is. So it's a baby teeth. Maybe the calcium in the baby teeth. Okay. So for 2 cities. So so again, they use this to prove that you do not need to check the requirements, because that's all the requirement we assume is true. And they want you to figure out using a 0.01 significant level test that the first city is greater than the second city. So which one is the right one? A, B, C. D, yep. So it's equal and greater than, so because it's a greater symbol. And then you need to find the test statistics. So what you do is, because I already import all your data here into your StatCrunch. So you go to stats, you go to T-stats, to sample, because we got data. So we will go with data. And then you just need to pick CD1 is the first column and CD2 is the second column. Okay, and leave the pool at blank, and you say it's greater, so we will do greater because your hypothesis says it's greater, and you compute. So this is your test statistic here, which is 1.48. Sorry, what happened? 2.48, and the p-value. I hope, yep. Usually I will ask for p-value. Where is my? There. 0.07 in 3 decimal places. 0.7079. And then after that, you will do the same thing. P-value is 0.079, alpha is 0.01. So is this number less than or greater than 0.01?
Greater than.
So if it's greater than, then we fail to reject or we reject?
Fail to reject.
So it's either A or C. And every time when you fail to reject, there is or there is not sufficient evidence to support it.
C.
Okay. So this is how it's kind of, so very similar to what you guys did. This is the one that you just need to import your data into StatCrunch and then you just do it. Tapu, are you okay here? Now, if you have any questions with 9.2, maybe you retry it. It's not that difficult. So I will because I need to go through 9.3 today, because that is the next section we have.
So if
done.
it was less than the alpha, then it would be reject.
Yes,
Okay, and alpha is gonna be always 0.01.
depends on the question.
Okay. Okay, cool. Thanks.
It is given the question. So this question is asking for 9.3 is a match pair. So this is where we talk about the before and after type. And we also talk about husband and wife. That means they are having a relation, some type of match or relationship. So that's the reason why that this section is a bit different. So we will begin to use the D notation in this case. Okay, so this is a little bit different from 9.2. So what is this D? This D is actually the difference between the first two and the second. So actually what happens with this dependent, because if you do the before and after, like your weight loss, what you do is you always subtract to find, is there any difference going on? So you always subtract the first one, means before you having the diet, and then with the after one. So you always do before and after. So you always subtract, if you put X population 1 minus population 2, okay, you always minus. Mu D in this case is mean difference. So this is the key word in 9.3. So every time when you hear the word mean difference, means that it is mu D. Okay, this is a population mean difference. Okay, D bar will be the sample mean difference. So the big word here is mean difference. So what happens in this is, let's say that we got students before and after, and let's say this is your weight loss. So let's say someone with 170 pounds before, after the diet, the student weighed 165. So the difference in this case will be -5 because you lose weight. Okay, negative. And then one person is 135. And before, after is 136. Now this person gained weight, so it's a +1. Okay. So what happened is that they will keep on, you have to keep on do. So let's say I got 50%, I will have 50 numbers here, right? And then I can find the difference. So what do I do with this difference is I find the mean of it. That means I add everything up. If it's a minus, I minus. So just sum this up and like a mean and divided by 50 people. This is what we call as D bar, the sample mean difference. And we can also find the standard deviation, and that will be what we call as SD. This is the sample standard deviation of the difference. Okay, and N is your sample size, 50 people also. Okay, so so when you do 9.3, we don't talk about mu1, mu2, 1, 1, 1, 2, 2, 2. No, we always talk about the D. So you see a lot of D here because we're doing differences between those two populations. The requirement says you have to have a match pair, simple random sample, and it has to be simple random sample. It has to be what else? My colors are coming up. So you have to be simple random sample, and your data has to be large enough, or your population is normally distributed. Again, if you don't have that, if you have a small sample, then make sure that you have no outliers. So this is exactly the same thing, same requirements that you have in 9.2, but this one has to be match pair. Okay, and you do not need to worry about doing all this crazy test statistics and all this thing, because StatCrunch will do for you. Now, when you interpret your confidence interval, we don't do plus. Oh, plus is you know, there are mu1, so we don't do that. Okay, So for this section, we don't do, oh, both of them are positive. Oh, you captured 0, a significant difference. No, sir. We don't do that. We don't talk about this. Okay, we don't do all this that you guys did. So we just go back to our normal interpretation. We are not, and the keyword here is mean difference. Okay, so that's the reason why that we don't use this interpretation in 9.1 and 9.2. In 9.1 and 9.2, we always want to tell us, are they both positive, or are they both negative, or are they 1 plus 1 minus, are they captured at 0, do they significant? Those are what you guys do in 9.1 and 9.2. But in 9.3, we go back to your old chapter 7, we are 95%, those are the one. And the big keyword here is mean difference. So again, class, every time when you guys do my finals or in my test, if you see the word mean difference pop out, means we are talking about 9.3, which is match pair. Okay. In StatCrunch, you just did stats, t-stats, and pair. Okay. So you so in StatCrunch, you just go through, I'll show it to you here. You go to stats, t-stats, and pair. Okay. And they will ask you again, the sample 1 is the first column, sample 2 is the second column, and then you do the mu-d. So you find out that your hypothesis testing is going to be mu-d here. So that is a little bit different from mu-1 and mu-2 that you guys did on previous section. Okay. Now, so when you run your hypothesis test, let's say I run through this, I'll show it to you. So I just do this, and I just do this is, let's say it's not equal to. So you will get this. This mean that you find here is your D bar, sample mean. This is actually is D bar, which is your sample mean. And as usual, the t-stat is your test statistic, and the p-value is a p-value. So those that I highlight is your important information, that if a question asks you for what is a D-bar, that's it, test statistic. And but your standard error here, do not use. Okay, degree of freedom is nice. I mean, nice. So standard error do not use. Don't standard error in this case is not SD, not this one. Sample set. So some students, some people question ask you for this SD. You cannot use this for them. Okay, so how do you find, I'm going to show it to you, how do you find the D bar and SD for this case? And the hint is always the first row minus the second row. So every time when you got this, it's all, if you want to figure out which one is the first one, always the first one is the first row, second one is the second row. So let's say that this is a question I'm asking for. You got of data about 5 different cars. There are 2 rating systems. One is an old rating and one is a new rating. And they want you to find what is D bar and SD. So how do you do this? So please pay attention because you need to do this in your homework here. So first thing first is you need to type this out. So I'm going to do very, so this is old and this is new. So what you need to do in this case, so the old one, you need to type this number up. If you have your homework, you can import it. So I will type 16, 18, 27, 17, and 33. The new one is 15, 16, 24, 15, and 29. So these are the old and new. So what do I need to do is I need to find the difference. So what happens in this case is, I should know how to, go to your stats, go to your t-stats, go to your pair. This is gonna be old, this will be new. Doesn't matter if you find anything. This is because we didn't do hypothesis testing. So you click on the difference. See, save the difference. You save it, and so you make sure you save it and you hit compute. So what happened in this case that they give us a new column called difference. So this mean, you see this mean is your D bar. So in order for us to find D bar, you just do your hypothesis testing. Doesn't matter if it's a left tail or right tail because it doesn't change. So your mean in this case is 2.4. But your standard deviation is not this number. Do not use this standard error. That is wrong. So in order for us to find standard deviation, you need to find the deviation of the difference. So you go back to your normal stat, summary stat, sorry. You go to stat, summary stat, and columns. Remember last time in chapter 3, you find the mean, standard deviation of this and that. So you go back, so stat, summary stat, column, but this time you pick difference and you compute. The mean is still 2.4, which is the same thing. The standard deviation in this case is 1.14. So this is done using summaries. This is done in your StatCrunch using stats, summary stats, and column. Okay, you go to stats, summary stats, and then column. And you pick difference, the column, the difference. And then you were able to get your D bar and SD. In general, what does mu D represent? So mu D in this case is your population mean difference. Okay? So that is the mu D means. So it's a population mean difference between the O and the new rating. So if you want to use this, so it's always, the keyword here is population mean difference between the O and the new rating system in this case. Okay. So this is how you figure out mu D in this case. If the value are changed so that it's expressed from kilometers to miles per gallon, how is the test statistic affected? How is the confidence interval limits affected? So if you change your units from one to another, your test statistic will be not affected. So your test statistic will be still the same. Okay, if this is 3.2, then the test statistic will be 3.2 if you change the amount per gallons. But for the confidence interval, it will change based on the conversion. So let's say the conversion is from kilometer per liter to miles per gallon is 1 to 3. So you multiply by 3 or divide by 3, then you have to divide everything by 3. So your confidence interval will change based on the conversion rate that they have. Okay, but your test statistics will be the same. Okay, this one, we get a 95% confidence interval and we get this. And then we also, if we treat the sample become independent, so this is treated as a dependent, you get this fellow. And the second one is treated independent, you get this fellow. What is the difference between the interpretation of this? So if you do the mu D one, which is the dependent one, then your interpretation will be, we are 95% confident that will capture the true mean difference. So this is the first one, the first 95. And if you are doing the mu1 minus mu2 then the interpretation for this is because one is negative and one is positive, so it will capture 0. So there is, if it's captured 0, there is no significant difference. This means mu1 is equals to mu2. So this is the difference between the interpretations of these two confidence interval. So if you have the mu d, which is a dependent one, then we use the VR 95%. But if you're doing the mu1 minus mu2, which is the independent case, then we're asking if that captures 0 or both positive, both negative, like what you guys did before. That is, and we don't, these two are not, there are two completely different ways for us to interpret. So be careful with this. Okay. You guys doing all right here? Right. So we'll talk about some examples here. Again, this is assumption is used here, so you do not need to check the requirements. So same thing happens in your finals. If I give you these assumptions here, you do not need to go through the requirement check in this case. So so what we do here is we look as a part of national health. So we ask for a height. So we ask for reported height, and we also ask for, then we measure the height. So what is going on in this case is we ask you, how tall are you? Okay, I am 68 inches. Okay, but then I really go and take a ruler and measure how tall you are. You are 67.9 inches. So this is reported and this is measured. So this is actually is a dependent case because I measure you twice. I mean, I ask you twice, I ask you one time, and then I measure it myself. So, so you want to figure, so part A is asking us is use a 0.01 significance to test that is no difference between the height of this. So for part A, you do not need to do the requirement check because of the assumption. So we can skip it. Okay. So when you do your hypothesis testing, we are not doing mu1 minus mu2, something like that. We are going to use mu d equals to 0. And your alternative is mu d. We are testing for no difference. So when you do no difference, what do you do here? Greater than, less than, or not equal to 0?
Not equal.
Yep.
David, I have to go, but
Yep.
I wanted to say your hair looks great today.
Oh, thank you. Well, watch the video.
I will.
Okay, and so this is the hypothesis testing that we have here. Then the next thing is we're asking for sampling distribution. So no matter, again, it's mean, so it's going to be T. Okay, I don't care if it's a dependent or independent, mu D or mu1 minus mu2, it's always T distribution because it's mean. And then now we need to figure out your sample, your test statistic and your p-value. So unfortunately, if this kind of questions coming up in your finals, you actually have to literally type this one out in your StatCrunch. So I'm going to use var6 and var7 here so that I'm going to move this away. Sorry. So so I'm going to use var6 and var7. So this is going to be reported. So you can actually click on the var and change. And this is measure. You can type in. And then you just type in the number 68. This is what happens when I give you your finals. You have to actually literally type this one out. And again, if you type something wrong, your answer will be wrong. And then this is 67.9. So this is something I will provide in the test. So it's not a lot to type in, but just spend some time on it. And I won't give you like a lot of data to type in. Okay, maybe something like this. All right, so once you finish typing all this in, so you go to stats, you go to tstat, you go to pair, because this is talking about dependent. Sample 1 is in the reported, sample 2 is in measured. If you want a difference, you can click the difference, not necessarily relevant. We are doing not equal to, so it's 0, not equal to, again, it's always 0. This is the one that is based on the question. So you hit compute. So the test statistic and p-value is given us by these two numbers. So your test statistic in this case is the negative 0.9 something. So it's the and the p-value is 0.3461. Okay. So it's the same type of next thing is to figure out if this is having, if your p-value is greater than or less than alpha, your alpha is 1%. So since this number is, so since your p-value is greater than your alpha, because alpha, so then you will have, in this case, you will fail to reject H naught. And then you just do the same conclusion. Since you fail to reject H naught, then I will consciously say there is not sufficient evidence to warrant rejection. Now, the reason why we use warrant rejection here is because you have the not equal symbol, equal and not equal. So no difference means same. So that's why it is an equal sign. So there is not sufficient evidence to warrant rejection of the claim that, you know, and then you put down the claim statement, which is there is no difference between these two. So, so this is how we do question A, the 6 steps of hypothesis testing. And then B is doing the confidence level in this case. So, so what you do here is you just need to go to your edit. Now you change the confidence interval, and we're going to use a 99% because it's 1 minus alpha, 2-tailed test, and you hit compute. So this is your confidence interval in this case. So your confidence interval in this case will be this answer. So it's kind of the same thing you guys did, negative 4.15, negative 4.156, and it's the other one, 2.156. So this is your confidence interval. So we do not, when I want you to interpret this confidence interval, I usually don't call you to interpret that. So how do we interpret this confidence interval? Because we are doing the dependent one, so we're gonna use the VR 90-some% confidence, so we don't use the capture 0 piece. So, so how do we interpret this is we are 99% confident that the interval from negative 4.156, this is all in inches, to 2.156 inches will capture the true value of the mean difference between self-reported heights and measured heights. So this is usually how we interpret your confidence interval is either we are using the old interpretation way that you guys did in back in chapter 7. So this is how we do this question in your chapter 9.3, where it's a little bit different than chapter 9.2, but you still follow the same old steps that we do, you know, for hypothesizing and the confidence interval. So so that's it for today here. So we are going to end today's class. So you do have one homework due tonight, which is 9.1, and then 9.2 and 9.3 homework is due next week. Okay, next Wednesday. So that 2 homework due next Wednesday. So I would recommend you guys to rewatch this video again because it is very important. This will be in your finals, and a lot of students get difference between 9.2 and 9.3 in the test, and they end up with big zeros on it. So make sure you guys try to do these questions here. Okay. So does anyone here have any questions for me before you guys go?
Yeah, I have a question.
What's your question, Rachel?
Yeah, I was a little distracted. I don't know if you did the B parts of 9.14 question 4, the B parts.
I think I did that
little
last
explanation. No, I mean the 9 is 9.1, the one that is due today. I think
Yeah, I think I did that question last week.
the question 4, the B part of it.
Yeah, you just need to, what you need to do for B part of it is a confidence interval, right?
Yeah, there's the way. Yeah, I did it the way I understood it, but they said it was wrong. Like I keep.
Do you
getting-
follow the 2-tail and 1-tail test that I show it to you guys? Linda, I will help you with 9.3 just after that. Do you know what to do here? Do you follow this when you do your, so this is
Yes.
question 4 in 9.1.
Sorry, let me look at it. I think I'm trying to.
This is, can you tell me what is the confidence level you use if I give you a 0.01?
When you give me a 0.0, I thought the one I have is 0.10, which is 90. I'm supposed to use 0.90, but I'm not getting the right.
Yeah, because this is the 1-tail test, right?
Yeah.
This is the formula you have to use.
Okay, so
if your alpha, you say your alpha is 0.10.
Yeah, it's 10, like 0.
It's 10, yeah, 0.10. Then what is your confidence level in this?
It's 90.
No.
Sorry, 0.90, I mean.
No, it's not 90.
Sorry. So you mean what you're showing me or what I have?
Yeah, right here.
Okay,
You say it's 0.10, right?
Okay, so that's 8. Sorry, 1 minus 2. Sorry.
Yes.
Yeah, 80, yeah.
That's why you use this one, which is wrong.
Oh, okay.
I told you, right, Rachel? This is very, very, very important.
Okay, 1 minus 2 alpha.
So you have to look for, is that 1-tail or 2-tail? This is a 1-tail, then you have to use this formula. If it's a 2-tail, then you use this formula.
Okay.
And yeah, so if you put 90% for this, then it's going to be wrong. It should be 80.
Yeah, I think I got it now. I was trying to
so
do
please, this is for all part B. So if you're doing 9.1, 9.2, 9.3 for part B, you have to know this.
Yeah.
Otherwise, you will get it wrong.
Okay. So
anyone have any questions besides Linda? Linda, what questions you have again? I'm sorry.
Number 6.
Number 6 on 9.3. So if you have questions, you may stay. If you have no questions, you may go. I will go to 9.3, right?
Yes.
I'm gonna let me stop recording.